Welcome back to another crash course where we take a topic and break it down to manageable pieces of information that you need to get started with it. So today we're going to be talking about the Git utility, and this is a command line tool very widely used in very many domains of software. It's kind of a must-have in the toolkit of any developer at this point. So this first video here is going to be kind of an introduction as to why and how you'd use this. It's going to be great for anyone who is a complete beginner. You probably should have some sort of experience on the command line and or coding experience using this, but it's not necessarily required. In video number 2 and 3 of this series, we're going to be covering some more intermediate and even advanced topics of Git. So if you'd like to, you can follow along from this video right here all the way to the end. So here are the topics. Let you peruse these at your own will. We're going to be going through pretty much all the basics of Git. So the question we need to answer first off is, why are we using this tool and what is it? Well, on this screen here you're going to see a little bit of a diagram that might not make a whole lot of sense, but Git is basically a tool that is, number one, distributed, meaning for a single Git repository. We'll talk about all this terminology in a minute. For a single Git repository, there can be multiple users and multiple copies of that repository. Just think about a file back before maybe Google Docs, where you can collaborate on a single file. If you just had like a Microsoft Word document, you'd have to basically email that back and forth to collaborate on it. And this has been made possible now by Google Docs, but truly Google Docs is using some version of source control, whether that be Git or SVN or whatever it may be. This tool allows you to create copies of the same file and allow collaboration on it. So that's kind of what I mean by distributed. Now, multi-branch management is going to be a little bit more confusing because we haven't talked about what a branch is. But if you take a look at the screen here, you can see that there's these different lines with the dots on it. So the dots will basically represent what we call a commit, or basically when you press the save button on a normal document, that would be the dot. And the different lines would be different like work streams. So you could have a single user for a single branch, and they could all have their own copy of that branch, and then once they're all done with their work, you bring it all together into a merge, and you've got a single document that has a history of all those changes. So that's kind of the power of Git, but no need to belabor the point. We're going to dig into this later and figure out hands-on how this is used. Our first order of business is to install Git on our computer if we don't already have that installed. It's going to be a little bit different depending on the system you're on. I'll just quickly walk through the commands. You can pick the one that's applicable to you. We'll start off with Windows. That's going to be Choco install. So you're going to use the Chocolatey package manager. And of course, on any system, you can always build it from source code, but usually it's easier to use a package manager. On Mac, it's going to be brew install Git. Pretty easy. And then finally on Linux, it's going to be sudo apt-get install Git. Next, we will need to set up some configurations. So go ahead and look at the screen and pick the one that is applicable to your machine. Basically, what we're doing here with this whole CRLF thing is CRLF has something to do with line endings. And since Git is a source control tool and it's going to check every single character of every file in your repository, the line endings that are made on different platforms are going to actually be picked up. So these will kind of eliminate any conflicts that you might have with those. Once you've set those configurations up, you can check them in the config file, which you can also edit directly. So that's going to be at the .git config in the home directory. You can see all of the configurations that we've made. Pretty much they all make sense. The only one that I would recommend if you are using Vim like I do is add in this editor equals Vim command, which will set the default commit message editor to Vim rather than, I think it might be Nano or something like that. So go ahead and set that. That's very useful in my mind. The next thing that we're going to do is a little bit advanced, and you're not going to completely understand what it's going to help us with until we actually learn the Git utility, but we need to set it up nevertheless. So just follow along. If you don't get what's going on, that's okay. You can revisit this section after the video if you need to. And that is going to be creating an SSH key. So the way that we connect to a remote repository is by either HTTPS or by SSH. And we're going to go on GitHub here to look at it. And in your GitHub, you will go to your settings. You go to SSH and GPG keys, and you're going to say new SSH key. And when you click that, it's going to ask you to enter a SSH key. And basically what this does is on your local machine, so the computer sitting right in front of you, you're going to have a private and public SSH key generated. And then on GitHub, you're going to have the public version of that private key. So basically, when you authenticate with GitHub and push your changes from your local repository up to your GitHub, it's going to check the authenticity of the SSH key in order to do that. So this eliminates the need for us to type in our username and password every single time we want to make a change upstream to our remote repository. Again, we're going to be covering all this terminology in a moment. To create this key, we're going to first enter the home directory, so type cd, and then we will run the sh keygen utility, give it an option T RSA because we want RSA version keys, and press enter. You're going to have to set up the default one, so this ID _RSA, it's going to be very important that you use that exact key because that's what GitHub is going to look for. So all you have to do really is press enter a bunch of times. So I'll press enter. It's going to ask me if I want to overwrite my existing key. I'll press yes, and then it's going to ask for a passphrase. I'll say I don't need to, so I'll press enter again, and it creates the key for me. Now that we have this key created, what we're going to do is print out, so we're going to cat out the public version of the key. So it's going to be in the .ssh folder, and it's going to be under id_rsa.pub. So there's actually a file called id_rsa. That will be your private key. You don't want to expose that to anyone. So we're going to cat out the public key, and it's totally okay that you on the video are seeing this because you don't actually see the private key that is behind this. So we'll copy that, we'll go back into the browser, and we'll paste that directly into the key portion. And what I'm going to type is Ubuntu updated key. When I press enter, it's going to add that SSH key to my keychain. And essentially what that's going to do is tell GitHub that my computer that I'm sitting at right now is authenticated to push and pull to and from GitHub. At this point, we are ready to create our first repository. And throughout this process, I'm going to be kind of explaining all the common terms that you'd find when talking about the Git utility. So we'll start off with the word repository because that's a big one. A repository is just a single container that has a bunch of source code. Now I know we're going in circles here. Source code is basically anything that is going to be part of a bigger software project. So it's just a fancy way of saying all the code in the project. So let's go ahead and create that. If we are in GitHub, we can come up in this right corner and click New Repository. I'll give it a name, so basic Git tutorial, and then some sort of description, video series. We're going to keep it public, and we are not going to initialize it with a README because we're going to do that manually. So all you need to do is type in the name of the repo and click create. When you create the Git repository, it'll take you to this screen, which shows you how to set it up. So there's about 4 different ways, but really we're only dealing with 2 different options that we can go with. And for learning purposes, we'll go ahead and set that up with both options. So we'll start off with the method of cloning. So the way that we do that is first make sure that you have SSH selected up here rather than HTTPS, because that is the whole reason we set up that SSH key. And then you'll copy this link right here. And we're going to create a directory for this particular repository. And the way that we do that is, I'm just in my home directory right now. We'll just say git clone, and we'll paste in the link that we had just copied. And by default, if we just press enter, it's going to create a directory called basic Git tutorial. Now I want to make a custom directory, so I will say basic Git tutorial -1. So this will be the first method of setting the repo up. So I press enter, and it says you appear to have cloned an empty repository, which is true. We have not added anything to it. If you cd into it, so basic Git tutorial 1, and type lsla, you're going to see nothing in it except for this .git. And this is actually a directory with, it'll eventually have all of our Git objects. So once we add stuff to our repository, it's going to kind of help keep track of that repository in this folder. And that's it. With git clone, you have completely set up your repository. Now, I want to go through a little bit more manual process for learning purposes and kind of understand what this is doing when we're cloning. So let's clear the screen and create another directory. First, let me get out. We'll create another directory called basic Git tutorial -2. And then we will enter that tutorial. And what we're going to do is now type git init. And what that is going to do is initialize an empty repository, or in other words, it's going to create that .git folder. Then what we need to do is add what we call a remote. And what I mean by remote is the server that we're going to be pushing and pulling from. You can basically think of this as GitHub, although there are other hosting services like GitLab or Bitbucket, or you could even set up your own on a server with like AWS or Azure or something like that. So when we say remote, just think of anything that's not directly in front of you. It's the computer that is hosting your repository somewhere out in the world of the internet. Now, what we mean when we say local repository is the one that is stored directly on the computer sitting in front of you. So what we're setting up right now is the local repository, but we need to tell the Git utility where our remote repository is at. And if you remember, we had this link here that we had gotten from GitHub. That is the link that we need to tell Git is our remote repository. So the way that we do that is we say git remote add origin and then paste in the link. Now we understand what remote means, we understand what that link is, but what is the origin? Now origin is basically like a default name that we will call this. We could actually call this anything, and it's just going to be the reference to that particular link. So I'll show you what I mean here. When we type git remote -v, it's going to print out the name of the identifier, which we just by default gave it origin, and then the actual link for our fetch, which means when we pull stuff from the remote repository, and then the push, which is when we take our local changes and push that back up to the hosted repository on GitHub. So like I said, you don't have to actually call this origin. You could call this custom origin, and when we type git remote v, you'll see that it added 2 more entries. And so now we could use either the custom origin or the origin to push and pull from this repository. And you'll see what that means when we get into the some of the commands related to this. After doing all those manual steps, we now have the same exact setup as we had when we did the git clone command. So we'll stick in this repository right here, and now it is time to actually learn the basics of Git. So in order to do that, we need to have some files, and I'm just going to create a simple index.html file. So we'll say touch index.html, and then we're going to use the vim utility to add some HTML to this. So let me paste some in there. It's just a basic web page that we're doing. And now that we have added that, we should have Git tracking all of our files. So if we now type git status, you can see that we are on branch master. We'll talk about that a little bit later. No commits yet. We'll also cover that in a second. And here's what we're interested in: the untracked files. Git has automatically detected that we have added a file to our local repository. So in order for us to take that file and add it to what we call the staging area, we can type git add index.html. And when we press enter, you don't see it do anything, but we'll type the git status command again, and now this message reads a little bit differently. It says changes to be committed, and you can see we have a new file in here. So now we took that index.html from our working directory and added it to our staging area. Now in order to what we call commit this to our repository, we have to run the git commit command. And basically what this is going to do is tell Git that we want to create a record of this file at this given point. So this command, the git commit command, is basically like a glorified Control S or save button on a document. The cool thing about it is when we do the git commit, as opposed to a save command, we actually take a little snapshot of the file at this given time that we can always refer back to. So we'll say git commit -m, and then we'll give it a commit message. If you don't do the -m option, it will just take you into Vim if you have it set up that way, as I had shown earlier, and it'll ask you for a commit message. So we'll just say -m, and then we'll say add our first file and press enter. And you see that what happened is we added our first file. It had 1 file changed, 9 insertions, so we had 9 lines, and it is in create mode. So we have made our first commit to this local repository. Now we're not quite done yet, because if we go back to GitHub and refresh this page that we're at, you're going to see that nothing has really happened yet. We're still, GitHub, the host of our repository, our remote repository, has no idea that we've done anything to this yet. Now, to let it know that we have done something, we're going to need to come back here and run one more command. So remember how we did that, we set up those remote paths. and I'm going to actually delete git remote remove custom origin because we don't really need two. So now if we type git remote, we just have this origin. And so what I want to do is I want to say git push. So we're going to take from local and push it out to our remote repository. And we want to say git push origin. So that indicates to Git that we want to use the URL that we had associated with the origin. And then we type master because we want to push this to the master branch of the repository up on GitHub. Bear with me on the whole branch thing. We'll get to it in a due time. You can see that without adding our username or password, we have pushed up to our remote repository thanks to the whole SSH configuration that we had set up earlier. Now, if we go back to GitHub and refresh the screen, you will see that we now have some information in our repository. You can check out the file here. This is what we just added. You see right here is the commit number, so we can click that. It shows you what we had changed in this commit. We can also see that we have only one branch right here. It's called master. That's kind of the default branch that will be created when at the first part of a repository. And we also have a complete history of what is going on. You will also notice that when we type git status again, it's going to say on branch master, nothing to commit, working tree clean. And that just means that we have everything synced up and our working directory, so the folder that we're sitting on in our computer is going to be the same as the staging area, which is going to be the same as the repository. So everything is synced up and clean. We will now create a change on the host. So the remote repository GitHub is another way that we can actually modify our repository. We can do it locally, which is what we did earlier, or we can do it remotely on the host server, which is GitHub. We'll click into index.html and press edit this file. What if we wanted to maybe add some body to this HTML document? We could say this is body text, and there's our change. Not a big change, but it is a change. We'll come down here and we'll say updated index.html from remote host. You don't need to add any optional extended description, and you can see that we have the check mark commit directly to the master branch. We'll commit the changes, and now what just happened is we have our remote repository, which is GitHub, and that is different from our local repository. If we come back to the terminal, you'll see that when we cat out index.html, we don't have that change that we just added. Now, if we wanted to get that change, all we have to do is pull the information from the remote to the local. So this is what we call pulling from upstream. So the upstream is the remote repository, and the downstream is the local repository. So we're going to pull downstream to our local repository by typing git pull origin master. So we're going to connect to the origin URL, and then we're going to pull from the master branch. When we do this, it will show a fast forward, and we have one file changed, and now we can cat out index.html and see that we have this body text right here. So pretty cool. This is the basic workflow and the basic commands of Git. So let me just review. We'll go through one more example to kind of show the workflow that you'll be going through when using Git. So the first step is going to be make changes. So we can create a new file. So new file.txt. We can edit that file. And then what we have to do is, now that we have edited our repository, we have to stage the changes with the git add command. So we can say git add new file.txt, or we can just put a dot to add everything in our repository. Make sure you check it with git status. You see that we have something in our staging area, and then we will commit with a commit message, added a new file. Once we have committed, we will push to our origin master. It pushes to GitHub, and then that is pretty much it. And if you have made changes, or maybe one of your teammates has made changes, you'll always want to start your day off by typing git pull origin master. And right now it's going to say nothing because everything is up to date. So that's the basic workflow. You just do that over and over again. Now I know it sounds very simple at this moment, but when we move into the second and the third videos, you'll see how this can get pretty complex, and you'll run into quite a few problems along the way if you're not careful. So I'd highly recommend you checking out those next two videos. I think you'll get a lot out of it and see the real power of using Git.